Hi, my name is Ali Bajwa and I'm a Partner Solutions Engineer at Hortonworks. Today I'm going to be going through the workshop steps for enabling security on the Hortonworks Sandbox virtual machine. To demonstrate how HDP security integrates with the enterprise's existing identity management implementations, we will set up a VM with FreeIPA server and configure it to talk to our HDP sandbox. First, a little about FreeIPA. IPA, which stands for Identity Policy Audit, is basically an integrated solution developed by Red Hat that wraps an LDAP, DNS, NTP, Kerberos server together. It makes it easy to implement a Kerberos solution and to get users access to a cluster. It's important to note that the same steps we'll be outlining here can be applied to other IDM solutions as well, like Active Directory. The first part of the workshop is around authentication, for which we will use Kerberos. First, we will install and set up IPA server and create the end users in groups. Second, we will install IPA client on our sandbox, which will allow its OS to recognize users in groups defined in a user directory without actually requiring a local Linux user account. Third, we will create the principals and key tabs and use the Ambari security wizard to enable security and authenticate all access to the cluster. Lastly, we will configure Hue to run in Kerberized cluster and integrate it with our user directory. The end goal is that users who want to run Hadoop commands from shell would require a Kerberos ticket before doing so. Also, the end user would be able to log into Hue without having a local Unix account. So let's get started. First step is to start a CentOS VM using an ISO file that I've previously downloaded. We want to make sure to increase the memory size to at least 2 gigs on that one. We're going to choose the install first option. This is essentially the CentOS install wizard. We can skip the media test. Once the wizard is up, you can just click most of the defaults, click next. Next for the languages. Basic storage is fine. We want to configure the name of the host, ipa.hortonworks.com, and we want to configure the network to connect automatically. Apply, close, next. We can pick the defaults for the rest. The root password we're going to choose is Hadoop to be the same as the sandbox. You can use all the space, click next, and write changes to disk. This will start installing CentOS. Once it's done, we're going to do a reboot and we should have the machine up and running. At this point, it's going through the reboot and login process. Now we have the login screen. Log in as root and Hadoop. Find the IP address. And from this point, we can actually use our terminal window on the local machine to access this machine. So let's set up our etc hosts entry to the new ipa.hortonworks.com VM that we set up. 211 is fine in this case. We can SSH into it as root. And now we're in. So first thing we want to do here is do a yum update. When that completes, we can turn off the firewall. Now we're ready to install the IPA server. So on this host as well, we want to add an entry for ipa.hortonworks.com into the etc. hosts. And now we're ready to configure the server. So we're going to pick the defaults, ipa.hortonworks, Hortonworks, Hortonworks. Password is going to be Hadoop, Hortonworks. It requires an 8-letter password. We're going to configure DNS and the reverse proxy. And that will start installing all the different components. So now the setup is complete. We can proceed. The next step is to set up each of those components to restart up on reboot. And we want to sync with the NTP server to make sure our time is up to date. Kerberos needs that later on. Let's do a kinit on the admin user to obtain the Kerberos ticket. And now we're ready to start setting up our groups and users. So first we're going to set up the LDAP groups. We have marketing, legal, HR, sales, finance groups. Then we can create a couple of users for HR, legal, and Ali, Paul, and XA Policy Manager users. Next step is to add the users to groups. So for example, the HR ones are all going to the HR group, the legal ones are all going to the legal group, and we've added Ali and Paul into the sales and finance groups. Next, we're going to set up the password. This is a quick and dirty way of setting the password for all those users as Hortonworks. It's entered twice into the file just because it requires the user to enter a password twice before it sets it up. So as you can see, we've changed the password for each of these users to Hortonworks. Get rid of the file. So at this point, we have the LDAP up and running. We can use JExplorer to browse the LDAP structure that we just set up. Let's take a look at the users and groups that we set up in JExplorer. There'll be a number of attributes that it created, and we can take a look at a couple of those. The connection is, as usual, at port 389 for an LDAP. So if you look at the Ali user and switch to the table editor, we can see the UIUD, the UID number, the posix account object class, the person object class, and finally the Kerberos principal name. Those are some important attributes that we'll be using later on. If we look at one of the groups, similarly we have the CN, the GID number, and the posix group object class as well. Again, that will be used later on. So next we're going to follow the instructions from section 1B to start up the HDP sandbox VM. So we're assuming here that the OVA file has already been downloaded, and what I'm showing here is we can import the Hortonworks sandbox 2.1 OVA into VirtualBox and configure its memory size to be at least 8 gigs. We're going to start up the VM, and it'll start bringing up all the Hadoop processes. Once the sandbox is up, we can take that IP address and add it to our local etc hosts so we can access it from our local terminal. We SSH into the box using Hadoop as the password. First thing, we can add the entry for the IPA host into the etc hosts. Make sure we can ping it. And let's go back to the IPA host and add an etc host entry for the sandbox as well, and make sure it can be pinged too. Now we can install the IPA client and also the Open LDAP client for LDAP search. Once that's complete, we can sync the time using NTP server. That way we make sure that the server, IPA server and client are both in sync. At this point, we can configure the IPA client. We pass in the domain of hortonworks.com, the server is ipa.hortonworks.com, and it should pick up the rest of the entries. We say yes to proceed. As you can see, it picks up all the entries, and we say yes and ignore the sync time issue, and it completes successfully. Let's look at the KRB file. The realms and the domain realms have been correctly created. We can confirm that. Next, we can look at the SSSD file that it configured, and it also shows that's been correctly configured. We can individually look at each of the PAM related files and look for the PAM_SSS, and in each instance we see that it's been correctly configured. So these configurations mean that the operating system should now be able to access the users that we configured in the LDAP on the IPA server. Here again we see the SSSD. Lastly, we look at the fingerprint file and again confirm that the PAM_SSS is present. Let's do a quick LDAP search to make sure from the sandbox we can access the IPA host and query the LDAP. Let's look for the user Paul. And we were able to successfully find it. Now let's test that the LDAP users can be accessed from the Unix file system. Let's look at the user Ali, and here we can see that we can pick up the sales and finance groups that we included Ali as part of in the LDAP. Similarly, if we do a groups on Paul, we see that Paul is also part of sales and finance. So here we see in one command we can essentially access both the user from the LDAP and from the local system. Next, let's start up Ambari. So log into Ambari on port 8080 with admin. And once it comes up, we navigate to admin tab and click security on the left hand side to activate the security wizard. Click next and change the realm name to hortonworks.com, all uppercase. Click next and do not click apply yet. We're going to download the CSV file and FTP it over to both the hosts. Let's FTP it to the sandbox first. Let's FTP it to the IPA server as well. Now we're going to move back to section 1A and complete the section that we didn't complete earlier. So we're going to VI the file that we just FTP'd over. And it's essentially a CSV file containing the principals for all the Hadoop components. So it's missing the ones for Hue and Knox, so we're going to add those at the bottom of the file. So it's essentially just a CSV representation of the same table we saw in Ambari. And the other change we want to make is move the resource manager entry to the top because of a bug. So just going to copy over the resource manager to the top and write and quit. So then we're going to run this command to create the Kerberos principals. You may get an error, a warning on this. You can ignore that. And here you can see all the different Hadoop components. We are creating principals for those in the IPA server. And then there's two services that we want to create, Ambari Q and HDFS. And now we can go back to the sandbox terminal and create the key tab files for those principals. So we're going to repeat the same steps on the CSV file here. Alternatively, you could have just copied it over from there, but I'm just going to repeat the steps here. So again, add the Hue and Knox entries to the bottom of the file. And then copy the resource manager entry to the top of the file. So the rest of the steps, we're just going to keep going on the sandbox. We're pretty much done with all the steps on the IPA server. We're going to do a kinit admin, enter Hortonworks as the password. We're going to create the directory for the key tabs and change the owner to root Hadoop. And then we're going to run this command to extract the principals from the CSV file and create a script to generate the key tabs. We're going to change it to execution mode. Let's take a quick look at it. And it's just a bunch of get key tab commands to get the key tab for a particular principal and stick it in the directory we just created. So let's go ahead and run that script. And you can ignore the couple of warnings it gave in the middle. Let's look at that directory. We see 17 key tabs generated there. Let's take a quick look at which key tabs were generated. And there you can see all the different Hadoop components, including Hue and Knox. We can do a K-list on one of the key tabs to see the principals that it contains. And then you can do a kinit as one of those principals to ensure that Ambari won't complain. So we're done with those steps. We can go back to Ambari and click apply to enable security and restart all the components. Towards the end, if the wizard errors out, it's sometimes just because the component didn't start up. It's fine. You can start it up yourself through Ambari. We just click done and go back to Ambari. And in most cases, notice that it says the Kerberos security is enabled, and in most cases you'll see on the dashboard all the services did in fact come up. So now let's try and test the enablement of Kerberos. If we go ahead and su to Hue user and try to read HDFS, we get an error saying that the user doesn't have a ticket. Okay, let's go ahead and do a K-list to confirm that, and then do a kinit for Hue using the key tab that we just created. That's worked fine. Once you do a K-list, now we confirm that Hue has a ticket now. Now let's try doing the Hadoop. Now we can access the HDFS. So with that, we see that we've successfully enabled Kerberos on our cluster. Now, if we go ahead and open up Hue, we notice that the file explorer is not going to, file browser is not going to work. And that's because we've enabled security, but Hue doesn't know about it. So next steps are to go ahead and make the changes in Hue to make it aware of Kerberos. For the first one, we have to make a change to the auth to local to essentially add the Kerberos principal to Hadoop user mapping for Hue. As you can see, there's mappings for others, but Hue is missing, so let's just add the rule for Hue. Once you make that change, you have to restart HDFS. Once HDFS is restarted, let's go ahead and edit the hue.ini file. And the first thing we need to do here is find all instances of security underscore enabled and uncomment them and set them to true. Once you've done that, you can find the Kerberos section in the Hue ini file, and that will contain the rest of the entries you need to change. So the first section is the Hue key tab that you can stay as is. The Hue principal needs to be changed here. So we're going to set it to Hue /sandbox.hortonworks.com at all caps hortonworks.com. That's the Hue principal we set up, and then you can just uncomment out the other values for Kerberos. And then you need to edit two entries in the beeswax settings. So change the beeswax server host to sandbox and uncomment out the beeswax server port. Once you write out the changes, let's restart the Hue service. And let's reopen the Hue web app and confirm that it now works. You'll need to do a refresh. And now we can access the file browser. You can check through beeswax that you can access the tables. And so Hue is now enabled for Kerberos. So let's log out as the Hue user and try to log in as one of the users from our LDAP, for example, Paul. Let's log in with Paul Hortonworks. And it doesn't let us. And the reason for that is we have not enabled LDAP on the back end yet. So let's go back to the Hue ini file and make the changes required to enable LDAP. So if you search for LDAP here, there's a couple of parameters you need to change. The backend needs to be changed from the default to the LDAP backend. The PAM service needs to be uncommented out. Change the base DSN to Hortonworks. change the LDAP URL, ipa.hortonworks.com. Uncomment it out. Change the LDAP username pattern. So this is essentially the LDAP query that Hue will run when it's trying to find all the users. We want to set create users on login to true. The user filter is the base filter when it's searching for the users. We're going to use the object class equals person. The username attribute we're going to use is the UID. The group filter can remain as is, and the group name attribute is also good for CN. So let's write that out and restart Hue service once more. We can also double check that the Paul user does not have a Unix account. Now let's go back to Hue and try to log in as Paul in Hortonworks. Need to refresh. And so now you're able to get in. You can access the file browser. You can confirm that the tables can be accessed as well as the user Paul. So this is the end of part 1. We have set up authentication. Users can authenticate using kinit and submit Hadoop jobs, or alternatively they can log into Hue and access Hadoop that way.